Okay, so we are looking at section 3.1. In this section, we're going to be learning how to solve quadratic equations by several different methods. One is by graphing, by using algebra methods as well. And we want to be able to solve real-life problems. So oftentimes we're said to be solving a quadratic. Well, that can also be called finding the roots. So if they say solve the quadratic, or find the roots, or find the zeros, find the x-intercepts, or find the solutions, all of that is essentially saying the same thing. A root of an equation is just going to be a solution of the equation. You may not have heard that solution called a root before, but it just means the same thing. What's the x value that makes the equation true? A zero of a function is an x value for which the function equals 0. So that's why all of these mean the same. So we can solve quadratic equations by graphing. We can just find the x-intercepts for this function. So if this y equals 0, then finding the x-intercepts is going to be solving the equation. Using square roots. If I have some value squared equals d, if I just take the square root of each side, I'm going to be solving the equation. We can also use factoring. If I have something in standard form, have the quadratic in standard form, I can just factor and use the zero property. So we're going to start by solving this by square roots. So because I have a quantity squared, I'm not going to multiply that out. I'm just going to subtract 1 from both sides. So that's going to give me x plus 2 quantity squared equals 4. I would now take the square root of both sides. The square root of something squared is just x plus 2. The square root of 4, because it's an equation, this could actually be positive or negative 2. Therefore, I would now subtract 2 from both sides, and I would have x equals 2 minus 2 is 0. Negative 2 minus 2 is negative 4. So 0 and negative 4 are going to be our solutions. So if 0 and negative 4 are going to be our solutions, that just means that that's also going to be where we have the x-intercepts. If I wanted to check this, I could go to y equals, and I could put this in. I could put in x plus 2 squared plus 1, and then I can put in the number 5. I do a zoom 6. Now this is going to look different from what I have here because here I'd already gotten it into a different form. But what I'm looking for is, what are those x values that make these two equal each other? Second, trace, find that point of intersection. Is this the first curve? Enter, enter, enter. And so one of my solutions then is 0. The other solution then, find that point of intersection. Enter, 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 and my other solution is negative 4. So these are going to be the two solutions. Okay? If I had subtracted this over and looked at the corresponding equation, those would then be the x-intercepts. But that would only be if I got it set equal to 0, which I did not do it that way. Alright, on this one, if I have two numbers that multiply to be 0, either this has to be 0 or this has to be 0. So I'm going to set this factor equal to 0 and this factor equal to 0. Solving this one, I'm going to get x equals 5 halves. Solving this, I get x equals negative 1. So those are going to be the two values that make this equal 0. Don't multiply it back out. It's already factored and set equal to 0. But look at this one. This one's factored, but it's not equal to 0. If two numbers multiply to be 7, it doesn't mean that they have to be 0. It means that they'd have to multiply to be 7. There are a lot of numbers that multiply to be 7. 1 and 7, 2 and 3.5, etc. So what I have to do here is I do have to multiply this one out. So this is x squared plus 4x minus 2x minus 8 equals 7. To solve, I have to get this set equal to 0. So x squared plus 2x, I'm going to have minus 8 equals 7, subtract 7. X squared plus 2x minus 15 equals 0. X and x, 5 and 3. I needed numbers that multiply to be x squared and numbers that multiply to be 15. And now I have to get positive 2 when I check my outers and inners. My outers would give me 3x. My inners would give me 5x. If I want to get a positive 2x, the 5x must be positive and the 3x must be negative. So now I have it factored and set equal to 0. So that now means x plus 5 must be 0 or x minus 3 must be 0. So x equals negative 5 or x could equal 3. Those are going to be the two solutions. On this one, this is not factored, so I have to get it set equal to 0. So I'm going to have 2x squared plus 11x, bring this over, so plus 5 equals 0. To do this, I set up my double parentheses. I have 2x and x. I need to get an 11 out of these outers and inners. I also have to have this times this equal to 5. I could have 5 here and 1 here. But if I do that, I'm going to get 2x and 5x. That's not going to give me 11. If I put the 1 here and the 5 here, now I'm going to get 10x and 1x. Those do give me 11 if they're both positive. And so now I have to solve. So x is going to be negative 1/2, or x can be negative 5. Those are my two solutions. All right. Now we're going to decide which method we want to use. Because this is a quantity squared, I don't really want to have to multiply that all out. So what I'm going to do is I'm going to add 19 to both sides. Now in this type, I want to have a perfect square over here. 81 plus 19 is 100. Take the square root of both sides. The square root of something squared is just 2k plus 3. That's going to equal plus or minus 10. So now I'm going to have 2k equals 7, or 2k equals negative 13. So my two solutions are going to be 7/2 or negative 13/2. Those are going to be the two solutions for k. On the next problem, I can see that I first want to eliminate the fractions. I'm allowed to divide an equation by the same number, and I'm also allowed to multiply by the same number. So I'm going to multiply through by 7 first. So that's going to give me p squared equals 5p squared minus 140. To solve this, I'm going to now subtract my 5p squared. So now I'm going to have 1 minus 5 is negative 4p squared equals negative 140. Divide by negative 4. So I have p squared equals, divide the top and bottom by 2, and I'm going to get 70 over 2. And so now I have to take the square root of both sides. Oops, that's going to be 35. So I'm going to have p squared equals 35. Take the square root, and I'm going to get p equals plus or minus radical 35. That's an exact answer. If I wanted the approximate answers, I would just do the square root of 35, and I get 5.92. So my approximate answers are 5.92 and negative 5.92. Exact, approximate. This one, think of the best method. Well, I can't take the square root of both sides because I have this x. So I'm going to have to subtract the 14x and add the 40. I want to get this side equal to 0. So now I've got x squared minus 14x plus 40 equals 0. Now I should be able to factor. I put my x and my x. Numbers that multiply to be 40 and add to be 14 are 10 and 4. When I do my outers, I get 4x. My inners, I get 10x. When I combine them, I have to get a negative 14. So therefore, my solutions are going to be 10 and 4. On this one, I can see that I have an x squared and an x and a number. So that means I want to get it into standard form set equal to 0. Add x squared, subtract 4x. I want to get it set equal to 0. So now I'm going to have 6x squared plus x minus 1. Set up our double parentheses. Numbers that multiply to be 6x squared, values, are going to be 3x and 2x. Values that multiply to be 1 are 1 and 1. When I check the outers, I get 3x. The inners, I get 2x. I want to get a positive 1. So the 3x needs to be positive, 2x negative. And so now I have to solve this. So I'm going to have 3x equals 1. X is going to be 1/3. Subtract 1. 2x is negative 1. And negative 1/2. Those are going to be my two solutions. If that went too fast, go back and try it on your own and slow it down a little bit. Looking at number 5. A skydiver drops out of an airplane that is flying at an altitude of 4,624 feet. Use the formula h equals negative 16t squared plus h sub o to write an equation that gives the skydiver's height in feet during free fall t seconds after the skydiver drops out of the plane. H sub o means the height at time 0. H means the height. T means the time. So I'm supposed to come up with an equation for the height. This is going to be my initial height, so that's h sub o. So I have h equals negative 16t squared plus 4,624. Read the problem. Use the formula to write an equation that gives the height. We did it. There it is. Is it possible for the skydiver to wait 18 seconds before pulling the parachute cord? Explain. Well, I want to know then, what is his height at 18 seconds? So I'm just going to plug in 18 for t. I could just do that by plugging it into my calculator, but I want you to get used to graphing. So we're going to go to y equals. I'm going to put in negative 16x squared plus 4624. I'm not going to want to do a zoom standard here. I'm going to want to change my window. X is the same thing as time. The lowest time I could have would be 0. The most time, they want me to check 18 seconds. So I'm going to make my most time 20. The lowest it could hit, I guess negative 10 would be underground by 10 feet. The highest, it's starting off at 4,624, so I'm going to go 5,000. Oops, not on my min. My min, I want to keep it. Negative 10 is fine. My Y max is what I want to be 5,000. So now I'm going to hit graph. Here's the way it looks. Here's the skydiver's height at time 0. Its height, its height, its height, its height. Okay? So to do this, I have two ways. I could look at the table, or I could just do a second trace, calculate a value at 18 seconds. And, the height at 18 seconds is negative 560 feet. So could he wait that long? Not a good idea, because he would already be 560 feet underground. Not good. If I take a look at my table, I can see his height at any given time. So he is going to hit the ground right there at 17 seconds, so he better not wait until 18 seconds. I would say he should probably pull that cord up in here somewhere. I don't think he wants to take any chances on waiting until the last second. All right, guys, that's it.